Lesson 101, Geometric Probability, and the appendix lesson, Factoring Quadratics. First, let's look at geometric probability. This is just a probability based on the area of the regions. So when we look at probability, you're looking at the chances of a certain event happening. In this case, a certain area, so a smaller portion of the larger area. So if you look at this diagram or this picture here, we have a square, and then we have a circle on the inside. The area of the square is the bigger region, is the whole thing. The area of the circle is the smaller section. So if we're trying to find the probability of something landing in the circle, we would look at the probability of landing in the circle, the area of the circle over the area of the square. And so you can see this one being done for us, and they give you a probability of 0.7852. So for the lesson today, we're just looking at the area of the smaller section divided by the area of the larger section. So let's take a look at an example. In a 12-inch diameter target is hit, what is the probability that a 4-inch diameter bullseye is hit? So to help with this one, it might make sense just to draw a picture. So here's the 12-inch diameter, and inside we have a smaller circle, which is 4-inch diameter. So we are looking at pi r squared for the small circle, and then we have pi r squared for the large circle. And so if we substitute our numbers in, so let's do the smaller one first. So the 4-inch, it means the radius is 2. So we have 3.14 times 2 squared. That'd be 4 times 3.14, which would give us an area of 12.56. And for the larger one, it's a 12-inch diameter, so that's 6-inch radius. So 3.14 times 6 squared. So 36 times 3.14 gives us an area of 113.04. So the probability that it lands in the bullseye, we would have 12.56 divided by 113.04. 12.56 divided by 113.04 gives us a probability of 0.11. So it's 0.1 repeating. Rounded off would be 0.11. So that would be the probability of landing or hitting the bullseye. The second one, what is the probability that an object that lands in the circle also lands in the square? So really they're asking you of it landing in the square, so landing in both shapes. So first we're going to find the area of the circle. The area of the circle, the diameter is 20, as it tells us right here that the diameter is 20, so that means the radius has to be 10. So we have 3.14 times 10 squared, which will give us 314. So that's our denominator. So that's the whole area of the whole thing. The area of the square is 10 by 10. So 10 squared equals 100. So we have 100 divided by 314. This will give us an answer of 0.3184 and so on. So we would round it to 2 decimal places, so 0.32. That would be the probability of landing in the circle, but also in the square as well. Next, find the probability that an object lands in the larger region will also land in the inner shape. So it has to be inside here, which is also inside the larger rectangle. So let's find the area of the larger rectangle first, because that's our denominator. So it would really be area of small rectangle divided by area of large rectangle. So the large one, 6 times 8 is 48. And the area of the smaller one is 3 times 4, which is 12. So 12 divided by 48 gives us 0.25. So we would have 0.25 as our answer. If you kept it as a fraction, you could keep it as 1/4. That would be the probability of landing inside there. The next one, find the probability that an object lands in the larger region will also land in the inner shape. So it has to land inside the triangle, which is inside the square. So area of square, and then area of triangle. So the area of the triangle, we have 6 times 8 divided by 2. So 48 divided by 2 is 24. And then the area of the square is 10 times 10, which is 100. So we got 24 divided by 100 gives us 0.24. Or if you want to put it as a fraction, we can divide this by 4/4. This would give us 6/25. Or you could have 6/25 as your answer. Next, find the probability that an object lands in the larger region will also land in the inner shape. So it has to land on this inner square here. So the area of the big square, 14 times 14, 14 squared equals 196 over the area of the large one, which is 10 by 10, which is 100. So we got 100 divided by 196 gives us an answer of 0.51, and that's rounded to the nearest hundredth. If we wanted to keep it as a fraction, 100 divided by 196, we can divide each of these by 4/4. 100 divided by 4 is 25. 196 divided by 4 is 49. So you can either have 0.51 or 25/49. Next one, find the probability that an object lands in a larger region will also land in the inner shape. So it has to land on the inner circle. So the area of the big circle, the radius is 10. It tells us right here the radius is 10. So we have 3.14 times 100, and that gives us 314 in the numerator. That's our smaller circle. So 3.14 times 36, because 6 squared is 36. Gives us an area of 113.04. We divide that by 314. That gives us a probability of 0.36. And if you wanted to put it as a fraction, we could have used this. We could have done it as 36 pi over 100 pi. Pi's would divide out, and then I can divide each of these by 4/4, and that would give us an answer of 9/25. Either way, fraction reduced or as a decimal to the nearest hundredth place. Next, which is greater, the probability that an object lands in the square or the probability that the object lands in the circle outside the square? So this one's a little bit different. Let's first find the area of the whole circle. So the radius or the diameter is 20, so that means the radius has to be 10. So we would have pi, I'm going to use 3.14, so 3.14 times 100, because 10 squared would be a 100. That would give us an area of 314. And the area of the square is 10 by 10. So 10 times 10 would give us 100. So the probability of that it lands in the square, so 100 divided by 314 would give us a probability of about 0.32. And then the probability of it landing outside the square. So when it says outside the square, so this would be in the square. If we were doing outside the square but in the circle, we'd have to take our two, everything's going to be over 314 because that's the total area. But we want to find out probability of landing right out here. So I need to subtract the area of the square from the area of the circle. So if I subtract 100, that gives me 214. And then I take 214 divided by 314. That gives me a probability of 0.68. So this is outside the square, but inside the circle. So which one is greater? Landing on the outside of the circle is greater because 0.68 is greater than 0.32. So just make sure that you read carefully what they're asking you to find the probability of. And our last part, the appendix lesson, factoring quadratics. When we factor quadratics, there are a couple of things to remember. First, the product of the two numbers inside your binomial. So here we have a trinomial, x squared plus 5x plus 6. When we're going to factor it, I need to have two sets of parentheses. These are my binomials. The product of the two numbers. So I need a number here and a number here. If I multiply those two numbers, that's going to give me, I have to find a number, two numbers that I multiply to get 6, but I add them to those same numbers to get 5. That's what this step means, and that's what this step means. So what is your first term in each binomial? It's whatever this term is. So if it's x squared, in order to get an x squared, I just multiply it by itself. So x times x gives me x squared. And now I need to think, what are two numbers do I multiply to get 6, but add those same two numbers and get me 5? This would be 3 and 2, because 3 times 2 is 6. 3 plus 2 is 5. And if I were to use FOIL, the method we used before, x times x is x squared, x times 2 is 2x, 3 times x is 3x, and 3 times 2 is 6. If I combine them, I would have x squared plus 5x plus 6, which is what I had here. So my answer in factored form would be x plus 3 times x plus 2. So let's try one ourselves. I have my two binomials. They both start with x. Now I need to find two numbers that I can multiply to get 6, but add them together gives me a -7. So I know 6 times 1 gives me 6, but 6 plus 1 does not give me a -7. What if I did a -6 times a -1? That will give me a +6. And if I add them together, -6 plus a -1 does give me -7. So I know this is a -6 and a -1. This would be my answer. Next one, two sets of parentheses. They both start with x's. So I need to figure out two numbers I multiply to get -6. And together gives me a -1. Well, I know a 6 times a -1 gives me a -6. But if I add them together, that gives me 5. So it cannot be that one. I have a -6 times a +1 gives me a -6. but a negative 6 times 1 gives me a negative 5, so it can't be that one. I can do a 3 times 2 gives me 6, but that's 3 plus 2 gives me 5, so that doesn't work. 3 times a negative 2 gives me a negative 6. 3 plus a negative 2 gives me a positive 1, so I'm close, but it's not that one. Negative 3 times a positive 2 gives me a negative 6. Negative 3 plus 2 gives me a negative 1. Therefore, my answer would be negative 3 and a positive 2. Here's my binomial. And our last one, I have x in both of them. I don't have a middle term. Whenever you don't have a middle term, that means one's a positive and one's a negative here. And I just take what number do I multiply by itself to give me 16. This is a perfect square, so this would be a positive 4 and a negative 4. So we would call this one a difference of two squares because I have a perfect square here and a perfect square here. Difference means I'm subtracting. And so you have the same binomial but with opposite signs. So the square root of x squared is x, square root of 16 is 4. One's positive, one's negative. The middle term will cancel off. So this would be my answer. So that is our lesson today on finding geometric probability and factoring quadratics.